Okay, this section is starting on 7.1. Now, so far everything we've done have been right triangles. Well, obviously not all triangles are right triangles. So now we're going to work what you can do if they're not right triangles. Now, if they're not right triangles, they're called oblique triangles. That's just the name for them. So oblique triangles. There's two ways to deal with oblique triangles. The first one is called the law of sines. The law of sines is a set of ratios. So it's proportions. Equal ratios are proportions. Now, you want to use the law of sines if you got a pair of opposites. Now, I use that term a lot. That means if you know an angle and its opposite side. Like if I have a triangle that looks like this. So if this is angle A and this is side A. If I know that pair, if I know angle A, if I know what its measurement is, and I know the length of side A, then I want to use the law of sines. Okay, so it's if you know a pair of opposites, an angle and its opposite side. Now you can do it two different ways. If you want to find the side, so again, it's just proportions. So it's side A over the sine of angle A, so that's over its opposite. Side B over the sine of angle B equals side C over the sine of angle C. We always label them so they're opposite like this. So if this is angle B, opposite side is side B. If this is angle C, the opposite side is side C. So they're always lined up with a pair of opposites. So here I have a triangle. I give you three things. Angle A is 32, angle B is 81.8, and side A is 42.9. When it says solve the triangle, that means you want to find the three missing parts. Now here first, since we're given two angles, we know the angles of a triangle add up to be 180. So if we know two, we can find the third one. So the first thing to do is take A plus B. Well, A plus B is 32 plus 81.8. That's 113.8. So if we subtract that from 180, the third angle must be 66.2. So that gives us angle C. So if you're given two angles, you can find the third one like that. Now, notice we have a pair of opposites. We have side A and we have angle A. So that means we can use the law of sines. Now, we need to use that to find side B and side C. Let's say we find side B first. I like to start with what we're going to find. We're trying to find side B, so I'm going to put that on top. Side B over the sine of its opposite angle. So that's the sine of 81.8. Now the pair we know. Side A, we want the side on top, 42.9. The angle on the bottom, so the sine of 32. So that's how we set it up. Now, after that, we're going to use our calculator. We're going to cross multiply and divide. So on these will always be in degrees, so make sure your calculator's in degrees. So if we cross multiply and divide, or divide and cross multiply, that means on our calculator, we can divide this side over here. So on your calculator, take 42.9 divided by the sine of 320. I'm sorry, the sine of 32. I can't read my own writing. Sine of 32. So we can divide that out. So we divided this side. Now if we want to get b by itself, we need to multiply by this denominator. So we take that answer times the sine of 81.8. And I get 80.128. Looks like this was to one decimal place. This side was to 1, so we'll use 1 here. So side B is 80.1 centimeters. Okay. Now we still need to find side C. Let's set up the law of sines again. We want to find side C, so let's put it on top. Angle C we said was 66.2, so on the bottom we put the sine of 66.2. Then the other side is the pair we know. Again, that's our A's. So side A was 42.9. Angle A, that's the sine of 32.0. And let's do that on our calculator. So again, divide this side over here. So 42.9 divided by the sine of 32. And then to get the C by itself, we need to multiply by the sine of 66.2. So times the sine of 66.2. And I get 74.07. We want to round that off to 1 decimal place, so that'd be 74.1. Okay. The law of sines is pretty uncomplicated, really. But you have to have a pair of opposites first. Let's look at this next one. Here, we're just given one angle, angle B, and two sides, A and B. But notice we have a pair of opposites. We have angle B and we have side B. That lets us know we can use law of sines. Now, since we're given another side, we're going to find an angle first. To do that, notice here we use the law of sines this way the first time. When you're trying to find a side, you put the sides on top. If you're trying to find an angle, you put the angles on top. So here, if we're going to do that, since we know that we're going to find angle A first, I'm going to say the sine of angle A over its opposite side, which is A, 189.6. Now the pair we know, so on the top we put the angle, the sine of 113.72 over its opposite side, 243.8. Now again, we're going to use our calculator. So we do that right side first. So we take the sine of 113.72, and I'm going to divide that by 243.8. So I get that. Now I'm going to multiply that. We got to get rid of that on the bottom, that 189.6. So I'm going to multiply that times 189.6, and I get 0.7119. Now notice we still have a sine A over here. So sine of A equals 0.7119. Well, now we just got through doing this in the last chapter. If we want to get A by itself, we take the inverse sine of both sides. To get rid of sine, we do the inverse sine. So while that's still on your calculator, you can hit second sine, second answer, right? Second sine and second answer. We'll just call up that last answer there. And it tells that answer is 45.397. Looks like our angle is correct to 2 decimal places. So A is 45.397 would be 0.40 when we round that up. So that's angle A. Well, now that we know angle A, we know 2 of our angles. So we can take A plus B. We said B was 113.72. We just found A was 45.40. If we add those together, that's 159.12. We're going to subtract that from 180 again because we know the 3 angles have to add up to 180. Well, if we subtract that, we get 20.88 degrees. Well, that's our angle C. Now to find side C, we go back to the law of sines. Now we're trying to find a side, so put the side on top. Sine C over the sine of its opposite angle, which is 20.88. Now the pair we started with, except we're going to flip it over this time because we want the side on top. So 243.8 over the sine of 113.72. And again, make use of your calculator. So I'm going to divide out that right-hand side. So 243.8 divided by the sine of 113.72. Now we want to multiply by the bottom of the other side, so take that times the sine of 20.88, and I get 94.911. So side C is 94. This is round off to 1 decimal place, so 94.9 yards. In general, I'd like to always have at least 1 decimal place, even if the problem didn't have at least 1, but normally you go by how many. So that's why the angles, there were 2 decimal places. So we found angle A and angle C to 2 decimal places to the nearest hundredth. The side was to 1 decimal place. Both of those were to 1. So I just used 1 decimal place there. All right. Now let's look at the next ones. Now these are some problems with this. We've actually done some of these before when we did like these with right angles. Here, got two cell towers on the left-hand side. So the first thing, you want to read the problem. Two cell towers, east-west, how far apart, talks about bearings. Now, draw a picture. Well, they're on an east-west line. So if we draw them, here's our two cell towers. So this would be west, this would be east. It says from the west tower, the bearing is north 42 east. Well, we did bearing before. Again, do exactly what it says. That says start from north. So from west, we're starting from north and going east 42. Well, east is to the right. So somewhere over here is 42 degrees. Then it says from the east tower, it's north 15 east. So we'll go from north. Again, east is to the right, 15 degrees east. Well, where those two lines cross, that is where our signal is at. Let's see, it tells the two things are 110 apart, so this is 110. So there's our picture. Now first, we need some angles in there. Well, here, it said this was north. It says this is an east-west line. So if this is 42, these two right here have to add, oops, doggone it. Sorry. So here from west, we went north, and we went east 42 degrees. So that's where that line came from. Then we moved over to the east tower. It said the bearing was from north 15 east, so we went right 15 degrees. So there's that one. Again, where they cross is where the signal is at. Now over here, again, we don't have any angles inside that triangle. We need at least one. We probably need two. So here, this was north. This is east-west, so these two angles have to add up to be 90. So if that's 42, this one has to be 48. Here, this is east-west. This line was north, so this angle right here is a right angle. So we had 90, and this one was 15. So this whole angle right here is 90 plus 15. So it's 105 degrees. Okay? You see how we got that? So 42 plus, we knew this was 48 because the north and an east-west had to add up to be 90. Here, this was east-west. This was our north line. So this was 90 plus that 15. That was 105. So we know those. We could find this one up here. Again, these two, we have the two we have. So if we take 48 plus 105, we have a total of 153. If we subtract that from 180, that means the other angle has to be 27. So this angle right up here is 27 degrees. Okay. Now, to use the law of sines, again, we need a pair of opposites. Well, if you look here, we only know this side, 110. Well, its opposite angle is this one up here, and we know it's 27. So there's our pair, 110 and 27 degrees. So that's our pair. So now, we want to find how far is the cell from the west tower. Well, here's the west tower, here's the cell. I'm going to call this side over here, I'm going to call it little e, just because this was east over here. So I'm going to call that little e. So to set up the law of sines, we have this side, little e, over its opposite angle, which we said was 105. So that's the sine of 105. Don't forget the sign there, that it's the sine of 105. Now that has to equal the pair we know. Well, we know this pair over here, the side was 110 and the angle was 27. So there's our law of sines. Now again, to solve it, we use our calculator. We divide out that right side. So on the right side, we take 110 divided by the sine of 27. Then we're going to multiply that times the sine of 105. And I get 234 point something. So we could say that side is 234 miles. Okay? Again, we've done that before. That's called triangulation. That's used all the time. It was adequate talking about cell towers because that's how, if you ever watch on movies where that's how like they do the find your phone. They triangulate it from cell towers. All right, this last problem, along with this, there are a couple of area of a triangle problems. Now we have, area of a triangle is 1/2 base times height, but that works really well if you have a right triangle. Well, if you don't have a right triangle, that gets a lot trickier. Well, here we can find the area of a triangle using if you're given side, angle, side. Do you remember that from geometry? Side, angle, side means if I have a triangle, if I know this side and the angle between them, that's side, angle, side. So if you're given side, angle, side, we can use this formula for the area of the triangle. We take 1/2 times the product of those two sides times the sine of the angle between them. So like if we take this problem that we did right over here, if I said, okay, what is this problem we just did? What is the area of that triangle right there? Well, we have two sides. We knew this, and we just found this side over here was 234, right? So if you look, we know this side, and we know the angle between them. So that's side, angle, side. So let's use that formula. Our area is 1/2 times each of the two sides, so times 234 times 110 times the sine of the angle between them, which was 48. So again, if you're given side, angle, side, so we look here, we know we found this side, so we had side, angle, side. So in the formula, we use those two sides and the angle between them. That is called the included angle, and that goes into our formula. Then we just do all that on our calculator. So I can do 0.5 times 234 times 110 times the sine of 48. 9,564. So 9,564 square yards. Oh, I'm sorry, these were miles. Sorry, square miles. So that's a lot easier than trying to, because the tricky part when you don't have a right triangle is figuring out what the height is. Because the height is perpendicular. We don't have perpendicular here. Okay? That's all for the first part of law of sines. That's 7.1.